So for the last unit review for the midterm, there aren't really explicit problems in there. It just guides you to the textbook to do some problems. And all the solutions should be there. If you have any questions about those, come and see me. But I figure we'll take some time. And I'll set this up using a calculator, and we'll look at some sequence problems just to help us out. I got 7 minutes to do this. So real quick, here when we set this up, we're going to have a system of equations: -4, -5, -1, -2, -5, -2, -2, 5, 2, x, y, z equals the constants 18, 12, 4. So what we want to do is we want to say, well, if we want to solve for x, y, and z, what we're going to do is we are going to take the inverse of the coefficient matrix, which, again, I get from all of the coefficients of the variables. Remember, inverse of this times the matrix of constants. If I take this and put this into my calculator, I'm going to get the answer for x, y, z. Okay, so let's actually do that and put this into the calculator. So we can put this into the matrix menu. So we go to matrix. We want to scroll over to edit, and we'll select the first matrix and make it a 3 by 3. Show my press history. And so the first row is going to be -4, -5, -1. So we do -4, enter, -5, enter, -1, enter. Second row is -2, -5, -2, -2, -5, -2, and then the middle row is -2, 5, +2. So -2, 5, +2. Once I have this all entered, I'm going to quit, go back to the matrix menu, and I'll edit my second matrix, which is going to be the matrix of constants. So it's a 3 by 1. So it's 18, 12, and 4. So 18, 12, and 4. Once I have that, I go back, I edit, or I quit out, and I'm just going to put this in my calculator. So I want the inverse of matrix A, so I do matrix A, hit that little inverse button, times matrix B, hit enter, and here we go. -4, 0, and -2. So if I write that as a list going down, -4, 0, -2, that means that x is -4, y is 0, and z is, not z, z is -2. And that is our answer. Make sure you write it as coordinates. All right, so for sequences, we can go through these real quick. Here, if I know that I want to find the first 5 terms, I need to know the first term. Well, this is the 8th term, and that's the 12th term. If you think about it, the 12th term, is nothing more than the 8th term plus 4 spaces. If this is a game board, I move 4 spaces. With each space, I add the common difference, d. So that's going to be, I'm adding d 4 times. So the 12th term is 42. The 8th term is 26. So this is going to help me find d. I subtract to get 16 equals 4d. So that means that d is equal to 4. If I have this, a sub n is equal to a sub 1 plus n minus 1 times d, I can choose either the 8th term or the 12th term. So if I choose the 8th term, a sub 8 is 26 equals a sub 1 plus, if n is 8, this is going to be 8 minus 1, which is 7, times the common difference, which is 4. So that's 28. If I subtract from both sides, I get the first term is -2. So 1, 2, 3, 4, 5. This is -2. My common difference is 4. I'm just going to add 4 each time to get this as my sequence. Pretty straightforward. Know the formulas, know how to work it out. Here, the sum of these The sum formula is S sub n is equal to n divided by 2 times the first term plus the last term. I know all of this. The last term is a sub n. I know all of this, I just don't know the last term. So that's what I'm going to do. I'm going to find the last term. I'm going to find the 10th term. So here, again, a sub n is equal to a sub 1 plus n minus 1 times d. The 10th term is going to be a sub 10. The first term here is 8. So if that's 10, n minus 1 is 9. And the common difference that I can see is 12. So 12 times 9 is 108, plus the 8 is 116. So that 10th term is 116. So the sum of 10 terms is going to be the first term, which is 8 plus 116. That gives me 124, and then I multiply that by 10 divided by 2, which is 5. So the sum of those digits is 620. Going down here, I don't really need to know the formula because this is a geometric sequence, which means I just multiply. So the first term is 2, and for each term I just multiply by 1/3, the common ratio. So that's 2/3, 2/9, 2/27, and 2/81. That's it. Pretty nice. And finally, I want to find the 10th term in a geometric sequence. So this is a sub n is going to be a sub 1 times r to the n minus 1. If I'm looking for the 10th term, that's a sub 10. The first term is 5. Here I can see I'm multiplying by 6 each time, and 10 minus 1 is 9. So 6 to the 9th power is what I need to do first. So that's 5 times this big number. And then I take that and multiply it by 5. So I get that the 10th number in this geometric sequence is this number. Put in my commas, and I'm good. So 50 million. So that's it for those. So make sure you go through the problems in the textbook, look at your formulas, and keep studying.